Alright then, welcome back everyone. Let's solve this question, different divisors. Now this is a beautiful question based on number theory, and I think this is the most difficult question of this playlist. So fasten your seatbelts, we are going on a amazing journey now. The concepts and mathematical intuition that combines to solve this question just blows my mind. So enough about that, let's just start this question. Firstly, they have given a definition of what is a divisor. So x is called a divisor of positive integer y if y is divisible by x. Okay, so that is the definition they have given. And then we are given this integer d. This d is a positive guy. We want to find the smallest positive integer a such that a has at least 4 divisors and difference between any two divisors of a is at least d. So the question is very simple, like the explanation that we are given a positive integer d, and what we want to output is smallest positive integer a, smallest positive integer, that is a greater than 0, such that it has at least 4 divisors and difference between any two divisors or factors is greater than equals to d. So that's the question for you. Okay guys, so before we proceed, I want that all of you are on the same level on how to calculate divisors of a number and like what are the number of factors given a prime factorization of a number. So I don't know about your knowledge on this, so I'm gonna explain it anyway. So let's say we are given a number here with this prime factorization, 7 square into 13 cubed into 19 power 1. How do you get the divisor set? Like how do you find all the divisors of this number? How do you form a divisor? Any divisor of this x will be formed by some power of 7 here, some power of 13 here, and some power of 19 here, right? So for example, 7 power 1 into 13 power 1 will be one of the divisor, or 7 power 0 into 13 power 0 into 19 power 1 will be a divisor, right? In other words, any power of 7 from 0 to 2 into any power of 13 between 0 to 3 into any power of 19 from 0 to 1 will form a divisor of this x, right? So 7 square into 13 power 1 into 19 power 1 is a divisor. In other words, the divisor set look like this. It's a Cartesian product of this set. 7 power 0 is actually 1, 7 power 1, 7 power 2 into 13 power 0, 13 power 1, 13 power 2, 13 power 3 into 19 power 0 is actually 1 into 19 power 1. So like the Cartesian product of this set will be the divisor set, and it's very simple to understand. What you're effectively doing is you're picking one of the powers of 7, you are picking one of the powers of 13 and one of the powers of 19. So this ensures that you are enumerating all the possible divisors of this number, right? So that's that. And if you want to find the number of factors, what is it? The number of factors is what? The number of guys in this divisor set. And that will be what? It's a classical permutation combination problem, right? So you have 3 possible guys here, you have 4 possible guys here, and you have 2 possible guys here. So your total answer is 3 into 4 into 2, which is 24. So how did it come? In the prime factorization, if the prime factorization looks like this, 2 power alpha into 3 power beta into 5 power gamma into 7 power delta, so on, the number of factors that you have is equal to alpha plus 1, because you have alpha plus 1 possibilities here, into beta plus 1, because you have beta plus 1 possibilities for choosing this power of 3, into gamma plus 1, into delta plus 1, so on and so forth. So this same happened here, right? So you had 2 plus 1 3 possibilities here, into you had 3 plus 1 4 possibilities here, and you had 1 plus 1 2 possibilities here. So that's why our answer came out to be 3 into 4 into 2, right? So given this prime factorization, these many number of factors you have. So with this ground clear, let's just proceed with the explanation. So how should you approach this question then? We want to find a positive integer such that it is smallest, it has at least 4 factors, and difference between any two factors is greater than equals to d. Let's try to make some observations. Now one thing is clear, that once the number of factors of a number increase, automatically the number becomes big, right? So they've asked for at least 4 factors, but let's try to make a number with exactly 4 factors, right? Exactly 4 factors, because the more factors a number has, the larger it becomes. Okay, that's one observation. So we want to make exactly 4 factors. So how will the factors like look like? You know that 1 is a factor of every number. So one of the factors will be 1 itself, and another factor will be the number itself. Then what will be the rest 2 guys? Right. So what I saw is they're asking for exact at least 4 factors. Since I want this guy to be as small as possible, let's try to get a number with exactly 4 factors, with this condition being satisfied also. So what will be those 4 factors? Now 1 will be of course 1, and another guy will be the number itself. Now what will be these 2 guys? I don't know, like I kept on thinking, but I was not getting anything. Then what I thought is, let's look this at a very fundamental level. So let's just assume we got our answer. Now this is a very common strategy, right? When you don't know the answer, assume the answer exists and try to simplify the constraints. Okay, but I know for the fact that I'm looking for a number with exactly 4 factors, right? Because that's going to minimize my answer. Okay, so let's look at the prime factorization of A and try to make some observations if we can get something out of it. Okay, so how should A's prime factorization look like? In general, how should a number's prime factorization should look? It will look something like this, right? So it will be like 2 power alpha into 3 power beta into 5 power gamma into 7 power delta. So prime factorization is simply all the primes with sum of the powers, right? So this is how any number can be represented, right? And we are now under assumption that all the conditions are being satisfied. In the sense, this A is smallest, it has at least 4 factors, and difference between any 2 of them is at least D. Okay, so if we know this about this prime factorization, can we get some idea, like can we get some idea about this alpha, beta, gamma? That's what I'm trying to see, right? So if we can get some idea here, then maybe we can get an idea how to fill these 2 gaps. Okay, that was my understanding. So let's see what can we do. So how many factors does A have? It is actually equal to alpha plus 1 into beta plus 1 into gamma plus 1 into delta plus 1, so on and so forth, right? Depending on how many primes it has in its factorization. Now notice one thing here, very important. If just any 2 of the powers are set, that is they are greater than equals to 1, just any 2, okay? So let's just say this alpha is set and this gamma is set. So this alpha is 1 here, this gamma is 1 here, smallest possible value. Then you will get what here? 2 into 2, 4, right? And what do you want? You want exactly 4 factors. Why do you want exactly 4 factors? Because A has to be as small as possible. These are the number of factors. If just any of the 2 powers are set, that is they are greater than equals to 1, you are getting what? If they are just 1 itself, right? So if this alpha is 1, this delta is 1, you get this guy total to be 2, this guy to total to be 2. All in all, you get 4 factors. In other words, you don't want more than 2 prime factors in your factorization, because setting more than 2 powers to be greater than equals to 1, you will get more than 4 factors. For example, if you have, let's say, 1 here, 1 here, and 1 here, then all in all you will have what? 2 into 2 into 2, 8 number of factors. But I don't want it. I want exactly 4 factors, because I want to minimize this A, right? I want the A to be as small as possible. All in all, what we have proven here is for this A guy, there are only 2 possibilities. Either it will have one prime factor in its factorization, so it will either look like this, so it will look something like this, either a p power alpha into q power beta, or it will look p power alpha, because more than 2 prime factors doesn't make sense, because it's gonna give you more number of factors, but we don't want that, because we want A to be as small as possible. So what will be number of factors in this case? It will be alpha plus 1 into beta plus 1, right? So this is the case where we have 2 prime factors and we want this to be exactly equal to 4, okay? And in this case, it will be alpha plus 1 equals to 4. So alpha is just 3 here, and here we know that we have 2 prime factors, so alpha and beta are greater than equals to 1. So here the answer is simply alpha equals to 1 and beta equals to 1, right? So because if alpha is 1 and beta is 1, then the total number of factors you will have will be 2 into 2, exactly equal to 4. Okay, so what it proves is when you have 2 prime factors, your number should look like P, alpha is 1, beta is 1, so P into Q, where P and Q are primes. And here our number should look like P cube, where P is a prime. Right, so effectively ये पूरी रामायण करने का यही मतलब था that now A can either look like this P into Q or A can look like this P cube. And how did we arrive at the solution? We saw the conditions, we looked at the prime factorization, we looked at how many factors we can have, then we figured out if A has to be smallest, then you cannot have more than 2 powers to be set. In other words, either A can be of form this, it can have 2 prime factors in it, or A can have 1 prime factor in it. If A has 2 prime factors in it, I want the number of factors to be exactly equal to 4 because I want to keep A as small as possible. If that's the case, alpha is 1, beta is 1. So A looks like this. Otherwise, if A has only single prime factor, I still want the number of factors to be exactly equal to 4. So alpha becomes 3, so it has to look like this. And how do those divisors look like? So in this case, what will be those 4 divisors that we are after? One will be 1, one will be PQ, and one will be P, and there will be Q. So these are the 4 divisors. And what are the 4 divisors in this case? 1, P cube, P, and P square. So you're gonna come a long way. So now what we effectively have is A should look like one of these, right? Either A is form of P cube or P cube, right? So what this effectively does is this simplifies our question. What we want to effectively find now is just find the smallest possible A of type this, find the smallest possible A of type this, and take the minimum of them, right? So just take the minimum of smallest possible A satisfying both the conditions. But you know that the first condition of having exactly 4 divisors, that is at least 4 divisors, is already satisfied when A is of type this, right? So if A is of type this, first condition is satisfied. Now you just find the smallest possible P cube which satisfies the second condition, that is difference between divisors is at least D, and smallest possible PQ where difference between at least 2 divisors is at least D, and take the minimum of these two, right, the smallest possible of them, which satisfies the second condition, which is the second condition, delta of Fi is greater than equals to D, and take the minimum of it. So yeah, what next then? How are you gonna do it? Let's handle this P cube case. Let's try to find smallest A which is of form P cube and satisfies this condition. So what are the factors here? The factors will be 1, P, P square, and P cube. Okay, fine. What do we want? Difference between any two of them should be at least D. Now one thing is obvious here. If difference between these two is at least D, difference between these two is also at least D because P square is anyway greater than P. Same grounds, difference between these two is also greater than equals to D. Similarly, if difference between these two guys is at least D, then of course difference between P and P cube is also greater than equals to D on the same ground because P cube is greater than P square. So what I'm trying to say here is it just suffices to check that difference between these two guys is greater than equals to D, difference between these two guys is greater than equals to D, and difference between these two guys is greater than equals to D. It by default considers all the possible cases, right? Yeah, okay, fine. So what next? Difference between 1 and P should be at least D. Okay. In other words, what it says is this P has to be greater than equals to D plus 1, right? Because in the worst case, if P is equal to D plus 1, D plus 1 minus 1 is just 1. So the difference between two factors here, two factors of this guy is still D. Okay. What do you know about P? This P is prime, right? So this P is prime. P is prime, P is greater than equals to D plus 1. My question to you is, can you find smallest prime greater than equals to D plus 1, right? Why smallest prime greater than equals to D plus 1? Because you want this A to be as small as possible, right? You know that this P has to be greater than equals to D plus 1, right? You know that P is prime. So if you find the smallest prime greater than equals to D plus 1, you are ensuring that this A is minimized. All that remains to be checked is whether P square minus P is greater than equals to D or P cube minus P square is greater than equals to D, right? See guys, P has to be greater than equals to D plus 1. It is prime. Now if the smallest prime greater than equals to d plus 1 satisfies these conditions, satisfies these three conditions, that you have ensured that your smallest possible a of type this. Simple, right? So let's prove that smallest prime greater than equals to d plus 1 satisfies these three conditions. Now the smallest prime greater than equals to d plus 1 definitely satisfies these conditions. Okay, because if p is in the worst case, the smallest possible prime greater than equals to d plus 1 is just d plus 1, then anyway this difference is d. Now come here, you know that p minus 1 is greater than equals to d, right? Because p in the worst case is d plus 1. Okay, I want to prove that p square minus p is greater than equals to d. How do you get p square minus p, by the way? P square minus p is nothing but multiplying this by p on the both side. So what is this? Is p square minus p, right? So p square minus p is actually greater than equals to d into p. You know that this p is positive, so it ensures that p square minus p is also greater than equals to d, right? So this p is positive, so dp is always positive. So p square minus p is actually greater than equals to d. Now I want to prove whether p cube minus p square is greater than equals to d or not. How do you get p cube minus p? Just multiply by p both the sides, right? So what is this? P cube minus p is actually greater than equals to d into p square. You know that p is greater than 1. So that's one thing. So you have proved it, right? Effectively, the smallest prime greater than equals to d plus 1 satisfies our second condition. Since you have chosen the smallest prime, you have effectively chosen the smallest possible a of type this. Yeah, fine. Makes sense. So for this case, you just have to find the smallest prime greater than equals to d plus 1. Now let's just consider PQ case. Then what happens when a is of type p into q? What are the factors here? The factors are 1, p, q, and pq. Fine. On the same ground that we have, if we satisfy the condition between these two, there is no need to satisfy condition between these two and these two, because I'm writing this in order, in the sense this p is less than q and this q is less than pq. Okay, so that's how I write it here. So again, we only need to ensure this condition between p and q is satisfied. We don't need to ensure that condition between p and pq is satisfied, right? Because pq is greater than q, right? And same condition only needs to be satisfied between q and pq. Fine. So we only have these three cases to consider here. To make sure that this p is as less as possible, this p will be what? Smallest prime greater than equals to d plus 1, right? On the same ground that this p has to be at least d plus 1 and p has to be prime. So to satisfy both the conditions and making sure that this a is as less as possible, you are picking it to be smallest prime greater than equals to d plus 1. Okay, fine. So that is p for you. What will be q? Now q cannot lie between 1 and p, of course, because q is assumed to be greater than p here. And q can definitely not lie, like q can definitely not be p. Okay, maybe I can write it in red color. Q can definitely not lie in p to p plus d minus 1, right? Because if q lies anywhere in this case, the difference between them is not at least d, right? So in other words, q has to be greater than equals to p plus d. So that is obvious, right? So otherwise the difference won't be at least d, it will be less than it. So that's not allowed, right? So my argument to you is, and you also know that q is prime, right? So q can be smallest prime greater than equals to p plus d, right? Simple, right? So p is smallest prime greater than equals to d plus 1, and so you know q is greater than equals to p plus d and q has to be prime. Why don't you find the smallest prime greater than equals to p plus d? This is going to ensure that a is as less as possible, right? Now all that remains is to check whether the difference between two factors is at least d or not. So let's just do it. Okay, so 1 minus p, like p minus 1, this you already know is greater than equals to d, because you have chosen p to be greater than equals to d plus 1, right? Q minus p you already know is greater than equals to d, because you have chosen q to be smallest prime greater than equals to p plus d, right? So if that guy is a prime, in the worst case it will be p plus d. So in the worst case, this will be p plus d and this will be p, so the difference is at least d. Okay, Now, what will be PQ minus Q? It is Q into P minus 1. This P minus 1 is at least T, right? So this all in all is actually at least T. So this is done now, right? So this works. The difference between these two guys is also greater than equals to D. Yeah, I mean, the question is finally done and dusted. All that remains now is implementing it, right? So how do you implement this? See, what you want to effectively do is find the smallest prime greater than equals to D plus 1 and find the smallest prime greater than equals to P plus T. Then you will have two candidates, P cube and P into Q, right? Where P is the smallest prime greater than equals to D plus 1 and Q is the smallest prime greater than equals to P plus T. Find the values of these two candidates and take the minimum of it. Right, so yeah, that's that about the concept. Let's just see the implementation because that's also one tricky part of this question.